Good afternoon, everyone. I'm Ronak Dewan from Eonics Digital. Firstly, thank you so much for taking out time out of your busy schedule and joining us for today's webinar. As you may know, the topic for today is data lakes for manufacturing, and the webinar is hosted by Eonics and AWS. Eonics took its first strides in IT in the year 2015, and with the help of a very tenured and a versatile team, we gained the competency of being AWS's advanced tier partner as well as SAP's gold partner. So our speakers for today are Mr. Meghnathan Mohan, he's the solution architect at AISPL, and Mr. Dhananjay Maheshwari, who takes care of business development at Eonics Digital. Before I proceed, I would just like to take you through a few hygiene points. Those of you who have joined us through their web browsers, unfortunately, you will not be able to unmute yourselves. So if you have any kind of questions, I request you to put it up in the chat box and we'll take it up with the relevant speaker. For those who have joined us today with their mobile apps or web apps, you can unmute yourselves. And if you wish to ask any questions, I request you to use the raise my hand feature on GoToWebinar, and I'll unmute you one at a time. If you have any kind of questions during the webinar, please feel free to put it in the chat box, and we will address it in the Q&A session at the end. So our first speaker for today is Mr. Dhananjay Maheshwari. With an experience of 10 years, he's an integral part of Aeonex's business development team. He'll be taking us through the value proposition Aeonex has to offer. So without any further ado, I would like to ask him to get us underway for today's webinar.
Hi, good afternoon, everybody. First of all, thank you for joining this webinar. So I am Dhananjay Maheshwari. I take care of business development with Eonics Digital. And so Eonics Digital, as Rohan described, like we are SAP Gold partner and AWS Advanced Tier partner. Apart from that, like we have other certifications, and so these are not mere the certification. This actually is the proof that we value the services that we provide to our customer, and we believe in the quality that we deliver. Currently, we are working with around 8 listed companies with 25 plus S4HANA implementation already been done, and more than 40 customers. So we are working on different SAP aspects. But apart from that, we are working with them for on SAP's workload on AWS. In AWS, we are helping our clients with many other projects like disaster recovery and other things, which I'll take you forward in the presentation. So currently, we have a team of 100 plus SAP's certified consultants, and we have 25 plus AWS cloud developers who are certified, and we have 1 lakh plus hours of consulting experience. The best part of our team is that most of us come from a business background, so we have a know-how and the understanding of the processes. So when we work closely with our customers, so it's not only about the current solution or the problem area that we want to solve for our customer. So we because we know the processes, so we help them to mitigate their current risk and keeping in mind their future aspirations. So when it comes to our cloud offering, so we do the systematic assessment of our customers' requirement apart from all the services like for their software as a service or infrastructure as a service or a platform as a service. But we closely work them to understand their requirement in the terms of like what is the solution that can be good fit for their organization, or probably if they have not considered certain solutions which like artificial intelligence, machine learning, IoTs. So we do the systematic assessment of their current landscape, their future aspirations, and according to that, we help them with the solutions which are efficient and effective in order to achieve their goals. So when it comes to the managed services part, so these are offerings. So it's not only the managed services, as I've told you, we do the assessment for them. So this is one of the one of the few offerings in details which we help our customer to uh, and as a SAP resellers, so we help our customers with all the different offerings. We are a reseller and a gold partner, so we help them with the consulting as well. So not only the reselling part, but we handhold them from the beginning of licenses till the delivery and moving forward. The other features like AMS or upgrades or other like in their whole journey of digitization, if I may say. So coming to the customers, so these are in last 1.5 year to 2 years. These are all the companies who are associated with us and gave us an opportunity to help them in their digitization journey. So if I'll speak about few of the use cases of AWS where we have helped our customers. So I'll take the example of Gopal Namkeen. So in Gopal Namkeen, we have helped them to integrate their production line using IoTs with their SAP. So what it helped them is, like, initially there was a lag in the data which is being uploaded to SAP. Now there is a real time update of data on SAP. So the productivity has increased considerably, because initially the observation and the manual entry used to take time, because somebody is observing and then they are doing the entry over SAP. It used to consume time for them, but now it's a real-time update of the data. The second example which I would like to put here is the Pilosa industry. So they are one of that very well-known textile manufacturer in Gujarat. So there we have helped them to establish their disaster recovery, and there were other issues in the sense because of their remote location. It was very difficult for us or for any cloud provider to get their disaster recovery easily on the cloud. But with the use of Direct Connect, we help them to establish a dedicated line, and then through their data center, we are directly helping them on AWS as a cloud. So it's not only the services, but it's the experience that has helped Eonics to reach to the customer and to help the customers. And they are once we have engaged with customers, so there are always many other projects which we help our customers with. So we are all exploring with different customers the capability of data lakes, artificial intelligence, machine learning, then intelligent document processing, and other form of AWS solutions which AWS provides to its customer. Uh, so this is my QR code. You can please scan my QR code, and if you have any questions, requirement, or any details you need from our side regarding AWS and other different services, please feel free to reach out to me over my email or my phone number, which is you'll get once you'll scan my QR code. So I'll wait for 10 seconds and then I'll hand over the presentation back again to Rohan.
Thank you so much, Dhananjay. Our next speaker for today is Mr. Meghnathan Mohan from AISPL. With an extensive background in as a solution architect, he'll be taking us through the topic data lakes in manufacturing. Mr. Meghnathan has 4 years of experience in data analytics. So without any further ado, I would like him to get us underway with today's topic.
Thank you, Rohan.
Hi everyone, can you hear me? Aruna, can you confirm whether you're able to see my screen?
Yes, Meghnathan, your screen is visible and you're audible.
Okay. Hi everyone. This is Meghnathan Mohan. I'm the solutions architect at AWS. Today I'm going to talk about data lakes for manufacturing. So let me quickly move on to the agenda. So this is what I'm going to cover, right? What is data lake and how to build a modern data strategy, and we'll see what are the benefits that offered by a scalable data lakes, and then like challenges in building a data lake. So this is very important, like key basically when customer try to build a data lake, right, there are many challenges they face, and how actually a managed service like lake formation helps them to build the to help avoid those challenges and bring easiest data lake into system. And then we'll talk about some of the key analytics like manufacturing analytic use cases. And finally, I'll show one reference architecture for manufacturing analytics. So overall, I'll try to cover this session within 40 minutes, and we'll take all your questions, right? Whatever you have, right? Please post it on the Q&A section, and I'll take your questions at the end. Okay, so before we move into what a data lake is, right? So I just want to help you understand what actually customer is looking for, right? So most of the customers, right, try to get value from that data. Because they have huge amount of data, but they don't know like how to process it to make it like helpful for deriving insight out of it, right? So as you see, right, the data are growing exponentially, right? We earlier we have like gigabytes and terabytes. Now that is not the case with the amount of systems we are integrating. That the data is now actually going like even like terabytes to petabyte to even exabyte for most of the use cases. So it's growing like the velocity, the volume it is growing is too high, and it's not able to handle, right, everything in an on-premise data analytics solution, right? So that's why like customers are preferring moving their data lake or data building their analytics workloads on the cloud. The second thing is like they're getting data from different sources. Like it's not like earlier in traditional on-premise way, right, we usually will capture the data from like transactional databases. Now right, we are getting data from almost all different sources. Like for example, it can be from an IoT device, it can be from a sensor, it can be from, say, for example, application logs, it can be from a clickstream data, or even from social media, right? From a particular hashtag we try to get a lot of data, and then we want to generate some like insights out of it. So the data is now like it's not like a single system where we usually traditionally used to get it, like transactional database. Now it is like a disparate system, so we need to connect and get those data so that we can derive insight out of it. And the third thing is like data is diverse. As I told you, right, there is no specific format of data that we get from different sources. Each, for example, we get from a transactional database, we get some structured data like relational data, for example. If we think about say like social media feed, right, we'll get like unstructured data. And similarly for IoT, another thing, right, we get some data which actually have semi-structured or unstructured in nature. So most of the data is not in a single format, right? So that's again another challenge, right, when you want to process the data. And after that, right, these data will be used by many people. So for example, with respect to data analytics, right, we have data analysts who use this data, and there will be data scientists who will use this data, and also for example, to process the data, there will be a data engineering team who will use this data. So we have many teams, right, across the organization use this data. And it also analyzed by many applications. So earlier, right, we used to have one it is a database, right? We try to use some business intelligence, right, directly plug in into the data source, and we'll try to generate insights. Now that is not the case. So we have data getting from different sources. we need to process the data because of the huge volume and huge velocity, right? We need some big data application to process the data. So to help that, right, there are like we need an integration to multiple systems like big data systems or like say ML or AL algorithms, right, to do some insights out of it. So these are the some of the some of the properties related to data. We'll dig into like what a data lake is. So basically, the customer objective is right. They need a data strategy, like to put a vast amount of data to work to get better decision. Like for example, they want to get some informed decision, and they want to improve efficiencies, and they want to respond to like response fast to like unexpected, and also they want to uncover new opportunities. So these are some of the key benefits, right? They want to get out of the data, right? That's what the customer is looking for. And if you see a traditional approach, right? So if you see on the left side, right? So we have multiple transactional database, like you can be an OLTP system or ERP system or CRM systems, where actually we'll move the data to a data warehouse, right? Where we keep all the data, like we consolidate everything in a data warehouse, and then we'll run a business intelligence tool like Tableau or something, right? We on top of it to generate insights out of the data. Similarly, right, for other source systems, whatever apart from databases, right? For example, consider there is an like IoT device or like sensors or say weblogs, right? Or social media feeds, right? All this data we'll consolidate in another data warehouse, and then we run some business intelligence on top of it. So you can see now clearly, right? There is a data silos. We are not keeping all the data in a single location. So that actually in turn help us to derive like not the exact information we are looking for. So to do that, right, the customers are now moving towards a traditional approach to say most of the modern approach, which you see on the right side. So we call it as a data lake. So I'll talk about what data lake is. Basically, right, all your source system, right, whatever it can be a database, it can be a device, it can be a social media feeds. We bring those data into a data lake. So data lake is think about a centralized repository where you keep all your data. It can be a structured data, unstructured data, or even semi-structured data. So all data, you keep it here. And then like all your systems, right, where actually you're going to consume it. It can be a big data processing system. It can be a log analytics system. It can be a data warehouse, right? All will be directly connected to your data lake, so that, right, you can say, for example, if you want to do some big data processing, you can directly pull the data from your data lake, do some processing, and then you can push the curated data back to data lake. So the data lake acts as an entire repository where you can keep your raw data and your curated data, whatever your cleansing and data cleansing and data curation, whatever you did, right? So after that, you keep your data again in your data lake. The reason being, right, we'll tell you what actually data lake is, right? So basically, you can connect. This actually has a integration to all the subsystems. So it can be a relational database. It can be a non-relational database. It can be like even if you want to run a machine learning model on top of your data available in say data lake, you can do that. You can directly plug in a machine learning model, and you can derive whatever model and whatever prediction you want to derive. You can derive directly out of it. So all these, right, are tightly interconnected, and it's a cyclic, right? So from any for example, right, from if you want a big data system to talk to a data lake and a relational database, you can do that. Similarly, for machine learning, I want to talk to a data lake and a big data system, you can do that. So it's all tightly integrated, and it's easy, right? So rather than doing keeping your data into silos, you are keeping all at one location. So again, what is a data lake? So data lake is a centralized repository where you keep all your data from disparate systems, right, into a single unified view. So moving on, so when you talk about data lake, right, in AWS, what is the best place to keep your data? So we have a service called in AWS. We have a service called Simple Storage Service, so which is actually an object store available in AWS, where like it give you, right, like unmatched durability, like 11 nines of durability. So meaning like there is no chance you lose the data when you keep a data, right? There is no less chance like you can miss your data on the S3 bucket. Similarly, like it's highly available. So we keep all like when you copy your data, right, in S3 bucket, we keep 3 copies of your data in 3 different data centers. So that, right, your data will highly available and highly scalable. So there is no restriction that you can even store exabyte of data inside S3 bucket. So there is no restriction in the amount of data you store it in a S3 bucket. And there are like many ways to get in data into S3 bucket. So there are like from a programmatic way, right, from your code, right, you can push your data from your on-premise system to AWS. from the console directly. You can log into AWS console, you can just upload your data, and there are like CLIs available. There are multiple options available. There are APIs available. You can directly plug and move your data between from different source system to S3. And it's easy to query and process the data in place. Like basically, right, what we are saying is, right, the data is still available in S3, but you can fire an like select statement directly from a different analytic system. So you don't need to bring the data from S3 to the analytic processing system. Rather, you keep your data in S3, but you can directly fire your query on like services like Adapt Query Analytics services like Athena, for example, right? And with respect to security, compliance, and audit capabilities, you can keep your data highly secure, right? We can define a lot of and like policies and everything we can configure on the S3 layer, and so that like you keep your data, like who can access which part of your data can be controlled directly using S3 bucket policies. And complaints, like for if you as an organization you have some complaints, like you want to keep your data encrypted at rest, and you want to say enable versioning on your bucket, right? You can do that, like whatever compliance requirement you have, right? You can configure that directly using S3 buckets. And also audit capabilities. For example, if you want to audit like who accessed the particular bucket, who deleted a particular bucket, right? If you want to take control of who did what, right? We have a service called Cloud Trial, which actually track all the API activities happen on an S3 bucket. So whatever activity that is performed by the user will be logged there, so that like we can easily find out if you have an auditing needs, right? You can easily find out by just browsing the Cloud Trial logs. And it is again, as I told you, right, S3 is the cheapest storage available compared to any other storage services within AWS. It's a cheapest service, and it provides multiple storage tiers. That is a tier called intelligent tiering, where actually, right, for example, we have a standard storage, we have a standard infrequent access, we have glacier deep. There are multiple storage tiers available depending upon your access pattern, right? How frequently you access the data, right? You can move data between different storage tiers. I think if you move to like archival solution like Glacier, right, the cost will be much cheaper compared to standard storage. So depending upon your use case, you can like define some lifecycle policies where you can move your data between different storage tiers. And there is a concept called intelligent tiering. This is again a storage tier. If you configure that, right, it will understand your usage pattern, and intelligently it will route it to different storage tiers. So again, you don't need to manually move the data, but this actually runs an ML algorithm behind the scene. It will take care of moving a data between different storage tiers. And as I told you, right, we have cold storage like Glacier and Glacier Deep Archive, where if you don't need the data for like say for example a past 3 years data or 6 years data, right, you can move it to a cold storage where the storage cost will be much cheaper. And you do have like say if you don't want the data after like 6 hours or 6 years, right, you can configure lifecycle policies or lifecycle rules, right? You can delete the data after 6 years. So all this can be done. That's why like most of the customer prefer S3 as the data lake. And to add on, right, we store all the open format. If you see, right, if you want to store any of the format, like can be an image file, it can be an audio or video file, it can be a web log, sensor data, right, documents. You keep everything since it's an object store, right? You keep all the files or objects directly into S3 bucket. And they also support various of open formats, like say for example, if you want to compress the data before you load it into S3 bucket, like for example ZZip format, or like say convert it into Parquet format, like which is columnar in nature, which is actually like like columnar format will help you to like query the data much faster with the minimum latency actually. So with the millisecond latency, you can access the data available in S3 bucket rather than if you keep it in a normal standard text file format, right? So these are some of the advantages that brings in like why actually people choose S3 as the data lake. Okay, so like again, we told you like data strategy is very important, right? For any organization to keep the data to derive whatever insight they want to do, right? So for that, right, we discussed about data lake, and we do have customer, right, prefer to use purpose-built databases. Like for example, there are customer which they want to store some key value database, key value stores basically, right? They can do it in a data lake as well, but they want to keep it in a like NoSQL database like DynamoDB. So they can do that, right? So it's not restricted that you need to use only S3 as your data lake. You can keep like a purpose-built database like DynamoDB, like even DocumentDB, right? Whatever, depending upon the use case, you can have your purpose-built database in place, and all your analytics system, right, big data processing system can directly integrate with your data lake as well as your databases as well, so that it's easy to connect any of your big data workloads. Pull the data from your data lake or from the database can be done easily. Similarly, right, the machine learning algorithm. For example, if you are building your own model, right, you are just using say SageMaker or any other machine learning model tools to build your model, you can directly pull the data, whatever you want to analyze, right? You can directly pull that from data lake or even from a database as well. So all are interconnected. So basically, whatever data source you have, right, you try to bring it to a data lake or a purpose-built databases, which actually can be processed using any big data tools or a machine learning algorithms. And this can be like, once you have this in place, right, in data lakes and the purpose-built databases, and all the process and curated data will be available either in a data lake or in a database that can be easily consumed by multiple people. It can be a data scientist in your organization, or can be a data analyst, right? They can easily access, or even applications, right? Whatever the downstream application which they want to consume the data, based on that they want to take a call, right? These applications can be easily tied to this system, so like either S3 bucket or like any database easily, right? Using a database connectivity, and then these applications can run, and whatever insights they want to develop, they can easily build that as well. So it's actually a better strategy compared to whatever traditional approach the on-premise system usually follow. And so I think that's what the modern data strategy is all about. I think building a data lake with a purpose-built database is what most of the customer follows right now. Okay. So what are the benefits, right? If you, for example, if you build a data lake, right, in S3 bucket, for example, S3, for example, what are the different advantages you get, right? So with the scalable data lake, when I say scalable, right, there is no restriction in amount of data you keep in an S3 bucket. You can keep like exabyte of data without any issues actually, right? And you can store any open format, like as I told you, we discussed on the previous slide. So you can keep any of the open format available, like it can be an Avro, it can be a Parquet file, right? You can keep it, and you can keep it in S3 bucket. And it is cost effective. We discussed about this, right? Because it's the cheapest storage available as far as any data storage is concerned. And the other key advantages, right? Any application, right? If you have your compute and storage in a coupled manner, right? There are chances that if you increase the storage, you need to increase the computing. For example, think about an EC2 instance, right? If you keep all your data in an EC2 instance, and your processing compute power is not able to handle the amount of storage, right? You need to move on to the next level. For example, if you're running 2x large, you may need to move to 4x large, because you need to expand both your compute and storage. But that is not the case if you decouple your storage with compute. For example, S3 is the storage, and it will automatically scale depending upon your storage needs. And the processing servers, like for example, think about Athena or EMR or any other big data tools, right? You can scale depending upon what the compute power you need, right? You don't need to depend upon how much storage you need to process. That is, both are like indirectly proportional. So you don't need to directly relate that. You can, depending upon your need, the amount of data you're going to process, you need to define the compute power you needed. So that's the power you get by decoupling the compute and storage. Okay. And S3 has a tight integration to all the big data tools, right? For example, be it an Athena, EMR, right? Whatever analytics tool you think about, right? It has a connectivity integrations available to all the data lakes, or even like SageMaker for ML algorithms, right? It's all integrations available pre-built for you, right? And you can process the data in place. We discussed about this earlier as well. So by using Athena, right, you can run fire and select statement directly from Athena without moving the data directly from S3. So data still resides in S3, but you can execute your code directly on Athena. So moving on, what are the challenges, right? This is the key point, right? So we talked about data lakes and what are the advantages that brings in, but building a data lake is quite challenging, right? So we'll see what are the different challenges the customer face nowadays to bring it. As you see, right, there are disparate systems. The data sources are coming from. It can be an on-premise application server. It can be a database. It can be from application logs. It can be from the social media streaming platforms, right? So it can be streaming using based on an API connect. So it can be anything, right? It can be a clickstream data. So data coming from a disparate system, and we need to move all the data to our data lake, which is S3 bucket, right? And so there is no standard ingestion algorithm available, right, to pull the data from all the different source systems, right? We need to define multiple pipeline to bring in the data from a streaming source. I need to have a different pipeline. For a database, I need to have a different pipeline, right, to bring the data to S3. So this is again first challenge. The second one is data management. Once you have the data, right, the data from on-premise server will be kept in S3 bucket. The database will be come to S3 bucket. So we don't know which data comes from which source, right? You need to properly define a configuration, like management activity, like how do you want to keep your database or source data into S3? How do you want to keep the application log in a particular folder in S3? So all this management will be like time consuming as well, right? So you need to properly plan that so that you can keep everything in a S3 bucket. And like once you have the data, right, I think the downstream application, or like for the consumer who is going to consume this data, right? It can be a big data system, it can be an ML model. Uh, to get the data right, we need to infer the schema out of it. So basically, the data will be, say, for example, think about an Apache log file, right? Apache log file contains a series of lines which contain exceptions factors, basically, right? To read the data, right, this system will not be able to directly do that. So we need a system in between, right? So basically, we need to crawl the data, whatever available in S3, and we need to define some schema out of it. Basically, we need to define a table out of it, so that like the next time, right, these applications know like when I fire the select statement, I'll get the data directly from Apache log, for example, right? So to do that, right, we have a service called Glue. Within the Glue service, we have a crawler. The crawler will crawl the data in S3 and define schema out of it, and it will store the schema in a data catalog. So data catalog is a place where you keep all your table schema information, or your database and schema information. So even though right, you are not running any database here, but actually you can see that think about that, it's actually whatever data you keep, right, act as a database layer on top of it, right? So the security and governance part will be challenges. Third part is like, as we discussed about the storage as well as the cataloging part of it. So who can access which table, right? So basically consider that if you have data like for 100 different tables, you can define a catalog, but not 100 table. We need to provide access to all the different services or people, right? We need to provide restricted access, like say for example 10 table for a particular business unit, or like say 20 table to a business analyst, right? So you need to control that who can access which part, right? The security and governance part. So this is again challenging. The fourth part is the integration, right? Integration to different big data processing, or like AML processing systems. Again, that is challenging. You need to write manually understand which tool will be helpful to process the data. And finally, like data sharing. So consider that you have an organization where you have multiple child accounts for each business unit, and you want to provide cross account access. Basically, right, you're keeping all your data in a centralized account in a S3 bucket, right? But all your child accounts will be in a different, for each business unit, there will be a child account which is under your organization. And you want to share only the data that is meaningful for them, right? You want to control access, right? So that can also be challenging, right? How you want to share cross account access for your data available in a centralized account. So these are some of the challenges, but there are services available that help you to address these challenges. We'll see in the next slide. Okay, so moving on, right? Again, we saw that at a high level what a modern data strategy is, right? So to deep dive into different AWS services that help you to build your modern data strategy. Say for example, this is your on-premise system where you keep your relational data. It can be, you can have your relational database. It can be an streaming data or other database, whatever, right? That doesn't mean that you need to keep everything in your on-premise. There can be some system which you are running on a cloud as well, right? It can be an RDS database. We want to pull the data, right? First thing is we need a connector. So think any data source, I need a connector. This we call it as an ingestion pipeline, right? With this pipeline, I cannot bring the data to my data lake. So okay, first I need a connector. Second thing is I need a catalog. Basically, I have the data in S3, but I want to read the data. To read the data, I need to define a catalog. That's what we discussed, a Glue data catalog, which actually keeps all your schema information, right? And then we need a transformation tool, right? Where actually I can transform my data, so that like, because whatever data you connect and bring in, right, it's a raw data, right? You need to do some transformation. Maybe for example, you want to do a deduplication, or like you want to do like you want to remove all the null columns in a particular table, right? All this thing you want to do, or you want to change a data type for a particular column, right, in a date column. Right? These are some of the things, or even some of the transformation which you may be interested on, right? As per the business use case, you want to do that. For that, we need an ETL tool, right, for transformation, right? All these three major tools are very important, and we do as a service, right? A managed service, but all this actually integrated into a single service. I'll talk about this in the next slide. So once you have your data in your data lake, there is a service called lake formation, which you're going to deep dive in the next slide. And we discussed about Glue a bit, and we talked about Athena as well. So these are the core services that is needed to bring the data, process the data. And then there are like a list of services which are easily integrated. For big data processing, we have an service called Amazon EMR, which is an Elastic MapReduce. This service will help you, like basically it's a managed big data stack available on the cloud. Whatever Hadoop or big data stack you're running on premises, right? You can run the same thing on Amazon EMR. And similarly for Aurora, it's a relational database. If you want to keep whatever you have in a relational database, you want to move it to a relational database on the cloud, you can do that as well, right? It's not restricted to use only Aurora. You can use RDS, or you can use any other NoSQL database as well, like DynamoDB, for example, right? And also for search, right, for do an active search on your custom search if you want to implement on your data, you can use open search service. This is again like managed elastic search service, which actually available for you as a managed services. And for data warehouse need, we have Redshift. And for ML, we have SageMaker. So all these are integrated to your data lake. So once you have the data in a centralized repository, right, all the other subsystem, all the other applications can easily access your data directly from S3 bucket and do whatever processing you want to do. So this can be easily done by using this framework, whatever the modern data strategy we discussed. Okay, so what is lake formation, right? I'll deep dive into this. Like, so basically, so as I told you, right, to set up a data lake is challenging. We discussed about multiple challenges, right? 5 different challenges we talked about in the earlier slide. So to address that, right, AWS come up with a service called like lake formation. So lake formation is like it's a managed service that helps you to build, manage, secure, and share data in data lake in days. Like within few days, right, you can set up everything. So basically, what actually it does, right, it will help you to build database-like features. So even though you're not keeping your data in a database, but if you can fire, like say for example, if you keep your Apache log in, say, or even say for example, IoT sensor data in S3 bucket, you can directly fire and select statement, and you can view the data directly from the text file that is available in S3 bucket, right, which is a data lake, right? Basically, it will create a database-like feature on top of it, database-like wrapper on top of it, right? That is the advantage you get it. The second is like simplified security management. So basically, right, we saw many different services, right? So you don't need to control access on each different services. Rather, you can directly control all the access part, who can access which service and which data, right? You can control directly from lake formation. So at one place, right, you can control who can access which part of your data, right? And it also provides self-service access to data. So for example, if I am a data analyst, if I log into my system and if I access an Athena service, I can see what I have been allowed to see, right? So I cannot able to see, for example, there are 100 tables in a data lake. As a data analyst, I'll be restricted to see only like few tables, like 5 tables or 6 tables. If the data scientist comes in, right, he can able to see like 10 different tables, right? You don't need to control that at Athena or other big data tools level. You can control access, right, everything at a data lake formation level, right? That is again a key advantage that brings in with the lake formation. And finally, right, data accessibility across your organization. We already discussed about it. For example, if you have multiple accounts or multiple business unit, right, each business unit has separate account, and you have a centralized repository in the parent account where you keep all your data lake. And then like you want to share the data to different cross account, basically across account, and you want to share only the data that is needed for the business unit, right? You can do that, control that directly from lake formation. So these are some of the advantages. Whatever pain points or challenges we saw in the data lake setup, right, this will be addressed using lake formation. So it's a one place service, right, where you can do everything at a single place. Okay, so there are three main part with respect to lake formation. First thing is you need to build the data lake, right? We'll see what are the different options available within building a data lake. So we talked about connect, right? When you talk about data lake, right, there is a connector, right? Basically, we need an ingestion pipeline to bring the data. For example, consider that if your source system is a database, right? I need to have a separate ingestion pipeline to bring the data from a, say, my relational database on premises. Say, for example, if you have an application server that's generating a logs, but I need to bring that log file to S3 data lake. It cannot use the same pipeline whatever defined for a database, right? I need to define a different pipeline to bring the data. So to help that, right, lake formation comes up with a blueprint. So blueprint is nothing but a template pre-built for you, right? If you want to connect a database, you can use that database blueprint. If you want to connect to an application log, right, you can have a different blueprint. So there are multiple blueprints available based on the customer use cases, right? And you can use that blueprint. By using the blueprint, right, you can create an ETL workflow. Basically, without any code, you don't need to write a single line of code. This particular thing, right, without any code, this will be automatically generated for you within the ETL workflow. Again, this is again using a glue service, right? Amazon glue service. So it will create a workflow for you, and then like using the connector, right, it will directly connect your source system. Consider if you have a database, it will talk to a database, pull all your data and store it in S3 bucket. right? And you can also manage your asset transaction, right? For example, if you want to keep your asset transaction property, if you want to stick it into your data lake as well, you can do that as well. Like Glue and there are like managed table that help you to support asset properties as well, right? So that's again most of the customer need it. I think that is also supported here. And a centralized catalog, we discussed about data catalog, right? Once you have your data in S3, there will be a crawler which actually Glue provides. It will crawl your data. So it will basically, it will understand what is the format of your data. Based on that, it will define some schema. Basically, it will create a table on top of it. Because you don't need a database to query the data, but the crawler help you to create a catalog, basically a schema, and then it will load it into a centralized catalog, which is actually, we call it as a Glue data catalog, right? So all your table schema information will be loaded here. So it's a centralized place where you can manage who can access which table. We discussed about multiple tables. So if you have 100 tables based on your data lake, you can control like the 5 tables can be accessed by say a data analyst and 10 tables can be accessed by any other users, right? You can control that. So you can control that by directly using centralized catalog. And you can optimize your storage as well. Like for example, there are multiple options available. We discussed about S3 storage optimization, right? For example, if you want to, there are multiple storage tiers available. If you want to optimize your storage cost, you can like compress it and you can convert it into column and format and you can keep it. And that will help you to optimize your data as well. So rather than keeping in like a huge file, right, text file or anything like that, you can convert that into columnar format like Parquet or like Avro or any other format, which will be compressed in nature and the size of the data will be reduced drastically, and your downstream processing application can be retrieve the data in a much faster rate. And it also Glue also provides some ML transform, like if you want to do a deduplication or if you want to do some other processing, right? So if you want to do from pre-processing before you move it to say S3 bucket, you can do that actually during the build process. So these are some of the advantages that brings in with lake formation. So moving on, the next important thing is like security. So this is again key factor, right? Once you have the data at a centralized place, right? You need the controls and management, right? Who can access which part of your data? How you are going to segregate the access part, right? So this can be, as I told you, right? It will provide a DB style permission, right? For example, in a DB, right, we can restrict row level access, even like cell level access, right? The same thing can be controlled in Glue data catalog as well, right? So you can secure like if you want to access like say only, for example, think about there is an employee database where you have a department column, and you want to restrict only HR department, right? To be assigned to a particular business unit, right? Where the data relates to HR team will need to be moved to allow access to a like HR business unit, for example, any business unit for that matter, right? So you can control that using DB style permission. And you can also, since it's S3 bucket, right, it do provide some permission boundaries, like where you can keep you can provide some like bucket level permissions, right? Who can access your data? Like bucket level, you can define like which are the users able to access your bucket and so on and so forth. And catalog, right, within the catalog, you can define some fine grained permissions as well. So whatever catalog we define, we can define fine grained permissions like say for example, this tables will be accessed by only this part of users and so on and so forth. And also you can, if you have multiple catalogs and if you are not able to control it, right, there is a feature called tag based control. So each catalog, right, you can define a tag is nothing but a key value per, like say for example, you can define an account ID or you can define an like environment is production, right, or a testing or UAT environment, right? Whatever you can control it by means of tag, and then allow access to different set of users. It can be an data engineering team, another team as well. So from the security perspective, these are like you can easily at a central place, right? You can control who can you can define and manage who can access like the security of your data as well as the governance part of it. So moving in, the third part is the sharing part, right? So once you have that data, you build the data lake, you secure your data lake, and now you need to share the data between different cross account, right? We already defined that, right? We can provide like access like fine grained access, whatever you control, right? And we can also define cross account access, like from the source, right? Producer can define who will be your consumer, and you can provide some grant access, right? You can provide like a select access or create access or drop access, whatever like DB level access you want to provide, right? There is a grant command which allow you to define delegated access to different users. And like once you grant an access to another account, right, that account will have grant, if they have the grant privilege, they can subsequently provide grant access to downstream applications as well. So these can all be controlled by using lake formation. And the catalog discoverability, as I told you, right, depending upon the permission that is defined in the catalog level, right, when an analyst log into an Athena, they can see only few tables, but if the data scientist logs in, right, they can see like more tables. Depending upon the access they provided, they can discover the catalog they will be eligible to see actually as well, right? And for all auditing needs, we have a cloud trial where we can audit all the activities, like whatever happened, who accessed the data lake, right, who copied the data, who deleted a file in a data lake. So all will be tracked in a cloud trial event, which can be easily captured at a later point in time if there is a need. We need to find it out as well. Okay? So for auditing needs. Okay, so these are some of the key manufacturing analytics use cases, but I'm not going to deep dive on all the use cases, right? These are some of the customers that are already using it, and they just deployed the data lake on AWS using S3 and other purpose-built databases, and they are just trying to derive insights directly out of it, right? So once you have the data in place, right, you can run any of your analytics use case which you want to run, right? You can run it on the cloud. But if you have a specific use case in mind, right, do let us know, like we'll help you on how to bring the data to a data lake. Again, this is an industrial like reference architecture for manufacturing data lake. I'll just quickly go over it at a high level. What are the different services we use, and then like if you have any question, we'll take it later. So basically, so this is your on-premises servers where you keep all your data. So it can be your like databases, like transactional databases, or it can be your devices, whatever you are using, like IoT devices, sensor devices that are using on your plant. And you can also have some ERP application that is running. So for example, if it is a database, right, we talked about multiple connectors. There is one connector called database migration service, so which we call it as a DMS. That easily connect using this service, right? We can easily connect your source DB, and then we can bring the data directly to a data lake, right? So this service will help you to talk to your connect to your data source system, whatever database. There are multiple options available where you can do like full load or like say CDC load, like full load with CDC. CDC is like change data capture. Like for example, if you do a full load, right, entire data whatever available here will be copied to a data lake, and then like if whatever changes happen, since it's a transactional database, there will be a multiple transaction happen after that. Whatever we do that, right? So all the change data, whatever happened on your source system, will be again migrated using the DMS CDC rule, whatever we define in DMS. It will capture all your change data, and then it will move it to data lake as well. So whatever data, like you can bring it to database, you can bring it using data DMS service. And if you have IoT like a sensor data, right, you can use like IoT core, and then like use this AWS service to bring the data. And we do have one more service called it's a streaming service. Again, we call it as a Kinesis data firehose, which actually pull the data from IoT core, and then like it will move it to S3 bucket, right? And similarly, we have if you have an ERP application where you keep all your data in say for example FTP server or FTP, we have a service called transfer family. So this particular service will help you to help you to bring connect your file FTP system, right, using like a secure file transfer protocol, and bring all your data directly to S3, right? And if you have already application on the cloud, and if you want to bring the data to a data lake, you can do that. Like say for example, we do have an API gateway, which is an API layer on top of your REST API services. And behind the scene, you can keep your Lambda function for pre-processing your data. You pull the data, do some pre-processing, and then you can load it into a relational database. And you can run an ETL job using Glue. So Glue is an ETL service. You can run an ETL job. We discussed multiple activities like Spark. You can run any of the like Python-based transformation or like Spark activity on Glue, and then it will process the data and keep it in a data lake. So all the different source system, right? Whatever we discussed, you can bring the data using different services, and you can bring it to your data lake. So within the data lake, we discussed about crawler. Crawler will crawl the data, and then like it will define some inference, and it will store all the schema information in Glue data catalog. And also the permission boundaries, whatever you configure, right, you can configure it directly from the data lake formation as well. So whatever lake formation we discussed, all the permissions and everything, security aspect of it, governance, everything can be controlled directly from here. And if you want to, like, data lake also provides an archival feature, right? For example, if you don't want to keep your data in standard storage, and with the access pattern, we are not accessing the data frequently, right, you can move it to archival solution. And finally, right, once you have the data, you have the ETL to process your data, And you can also run visualization. Like the third main key part is like, say, have an ingestion and processing. The final part will be visualization, right? You can visualize that data that is available in your S3 curated data that is available using like Athena and QuickSight. Right? These are the two services that help you to like visualize your data directly on top of S3 and Athena. And finally, if you want to run some machine learning models, if you want to bring your own model, or if you want to define your own model, right, you can do that using SageMaker. So it will help you to build, train, and deploy your model on the cloud. And it's a managed service again that help you to define any predictive algorithm. If you want to run it, right, you can run it directly on the SageMaker as well. So these are at a high level, right? I'm given like different options available to bring the data onto the cloud. I think. Okay, I think I'm done with that slide. Do you have any questions? Like, let me know. Like, any other questions available in the chat window? I'll take it one by one. Uh, if you have any question, like, please unmute yourself. Like, or like, Rona can help you unmute them. We can get the questions one by one.
Yeah. Thank you so much, Meghnadhan. I'm sure your presentation was very insightful for everyone. Like Meghnadhan said, if you have any queries, please feel free to raise your hand or put it into the chat box and we'll take it up. So I think we have a question from Priyanka. I'll just unmute her. Yeah. Priyanka, you're now audible. You can ask your question.
Hi, this is Priyanka. I have already put it my question in the chat box. Anyhow, I'm going to ask, how can I bring the transactional database data into the data lake?
Okay. Okay, I'll happy to answer your question. Like, say, as I told you, right? Like we have, if we have a transactional DB, right? What you can do is, right? We have a service called database migration service, and we have a service called Glue, right? These are the two different services that help you to connect your transactional databases, and you can define like jobs directly in a database. It's basically database migration service is actually a tool, like it's basically it's a tool running on top of an EC2 instance where we define what is our source system. Right? In your case, right, it can be a transactional database which is running on premises, and the target can be a relational database or like S3 bucket. Right? We can configure that in a database migration service. What is your source endpoint? What is your target endpoint? And then like you can configure like the connectors, right? Basically, what is your endpoint of your database? What is the username and password to connect it, right? Once you have that everything in place, right? You run the task directly on the DMS service that will directly do either a full load can be done, or if you want full load with CDC, you can do that as well. So it's a recurring task running behind the scenes. Whatever changes that is happening on your transaction data, it will automatically pull it and put it in your data lake. Did that answer your question?
Yes. Thank you.
Okay. Any other questions from anyone? Like we can take it. Like we have another like 8 minutes time. We can take any questions if we have any specific on data lake or like how to build a data lake and like whatever we discussed today, right? If you have any questions related to that, please let me know. I'll answer your question.
So we'll just wait for a couple of minutes. While we are waiting, I'm posting a survey link onto the chat box. We would really appreciate it if you guys take out a couple of minutes and answer the survey. It will help us deliver webinars in a much more efficient and productive manner and improve our delivery. So we have another question from Pradeep. What are the connectors available to bring the real-time streaming data to data lake?
Okay. So if you have a real-time streaming data, for example, consider that you have, like say, for example, there is an event happening on, like say, Twitter, and you have a Twitter handle, and from your application, right, real-time, you want to analyze the sentiment analysis. So I'm just giving a use case, right? If you have that kind of a use case, we have a connector available. Like we discussed about Kinesis here, right? And similarly, we have one more service within the same Kinesis family. We have a Kinesis data stream, right? It has a connector to your streaming services, like say it can be an API layer, it can be say for example application logs, right? For example, if you have a running huge amount of application log that is generating and you want to keep analyze the real time on the cloud, you can like plug in, you can use that Kinesis data stream that actually install an agent on your on-premise system. So as soon as there is a new log generated on the backend system or an API call generated event, right, on the backend system, it immediately the agent will pick that information, like directly post it to directly using the Kinesis, it will directly post it to Kinesis data stream, right, which is actually an real-time streaming service. Oh, it's not real-time, it's a real-time, right? It's not real-time as well. So Kinesis Firehouse is a near real-time, but when you want real-time, right, Kinesis data stream will be helpful for you. So as soon as you get the data, it will be directly pull the data directly to push it to say Kinesis data stream, which again you can directly connect to the consumers, right? Consumer in this case can be a Glue, right? It can be an big data tools like Spark streaming, right? Whatever you want to process it, right? You can process it on the fly, and then like you can derive insights directly on top it with real time.
I hope that answered your question. If there are any more question, I'll wait for another minute or so. We are more than happy to take up more questions. So Priyanka has another question for us. Uh, are there any use cases in manufacturing, automobile, or chemical?
Like that's what we discussed, right? So we have multiple use cases actually. Maybe like if we have a specific use case in mind, right? Just do let us know, like either Dhananjay or myself, right? Just help us understand what your use case is, right? There are multiple use cases that a customer using. There are multiple case studies as well, right? Maybe I'll help you to assess with respect to use cases what we did and how we did, right? So we have everything available within the open documentation available on the AWS website. But if you need specific to a specific use case in mind, right, just let me know, like I'll help you like how to bring the data and how to like bring the data onto the data lake and do further processing as well.
So I guess there are no more questions coming on. I would like to thank everyone for taking out your time from your busy schedules and attending today's webinar. If you have any follow-up questions, please do not please do not hesitate to get in touch with either Meghnathan or Dhananjay. It was a pleasure to get an opportunity to host you guys today, and we hope to see you soon again. Thank you so much. Have a great day ahead.
Thanks everyone for attending this session. Thank you so much.
Thank you, everyone.